Welcome to class 10th mathematics. Let's learn the trigonometry in this video. Okay, as usual, we'll follow the Telangana class 10 syllabus. Okay, and then after that, I will make some more videos based on trigonometry questions for useful for Olympiad as well as other entrance exams. Okay, so let's get into the chapter. In this chapter, what we'll cover it mainly trigonometry is a very small and precise syllabus for a 10th class student. Okay, you will mostly learn the trigonometric ratios of complementary angles, and some of the trigonometric identities, not all. Okay. Okay. All these are very useful. Trigonometry is very useful not only in maths but also in your physics. It's very useful. So give utmost importance for the theory part of it. These are the basics, as I said, always very useful later in your 11th and 12th. Okay. Let's get into the trigonometry now. Let's first see the introduction. Okay. Yeah, trigonometry is basically talks about trigonometry. You can see, so it talks about the triangles only. Okay, and it talks about the relation between angles and sides of a triangle. Okay, angles and sides of a triangle. This is the most important thing you should know about trigonometry. What is the relation between the angle, that is, if you see here theta, and these sides of this triangle? Okay. This is what we'll learn in trigonometry. Okay, there are various examples in nature where you see angles of a triangle. Okay, angle here, okay, angle here. You can find even angle here also, right? You will see various examples. Okay, but trigonometry gives you information about how these are all related, angles and the sides of the triangle. Okay, so let's first name the sides of a right angle triangle. Okay, so that we are all on the same page. Okay, if you take ABC as a right angle triangle, ABC is a right angle triangle, B is at 90 degrees, angle B is 90 degrees. Okay, so if you say ABC with the capital letters here, the sides of triangle will be opposite to B. Angle B is the small b, this is the hypotenuse. Opposite to angle A will be small a, this is the side opposite. Okay, opposite to angle C, you will have C, small c, this is the side AB. Okay, this is one. Now we call if you take angle at one of the acute angles, not the 90 degrees one, okay, not the right angle. If you take one of the acute angles, okay, let's say A is theta, okay, and from this theta point of view, from this angle point of view, okay, AC is the hypotenuse, biggest side, okay. BC is the opposite side to this angle. Okay. AB is adjacent to this angle. Okay. So this is the notation which we will follow it, and based on this one, we'll give the trigonometric ratios. Okay. So if you take this section, if you see PQR is a right angle triangle. For angle R, he is asking for angle R. What is opposite side, hypotenuse and adjacent side? Hypotenuse is same whether it is for angle R or angle P. Okay, which is PR is the hypotenuse, which is the biggest side. Okay, PQ is opposite. Okay, QR is the adjacent for angle R. Okay, now here in this case is asking for XYZ triangle. From angle X point of view, what is hypotenuse is XY, opposite is YZ, adjacent is XZ. Okay, from angle Y point of view, opposite is XZ, adjacent is YZ, hypotenuse is same XY. Okay. Now, write the lengths of hypotenuse, opposite and adjacent side for this given angles in the triangle. Okay. If you take from angle C point of view, okay, from angle C point of view, we know that this is a right angle triangle. Okay. So, if you apply Pythagoras theorem, you will get the AB, side AB, which will be 3 centimeters. Okay. 5 square minus 4 square and square root of it. Okay, which is 25 minus 16, 9, square root of 9 is 3. So 3 centimeters is AB. From angle C point of view, opposite is 3 centimeters, adjacent is 4 centimeters, hypotenuse is 5 centimeters. From angle A point of view, opposite is 4 centimeters, adjacent is 3 centimeters, hypotenuse is 5 centimeters. Okay. So this is the notation which we'll follow. Then what is trigonometric ratios? Okay. Let's do a simple exercise. Let's draw a triangle like this. Draw AE. Okay. A big line, and then another line AY. Okay. A bigger line. Okay, and you can make several right angle triangles in it. Okay, you take any point on this AY, draw a perpendicular from there onto AX, you get a right angle triangle. Correct? You draw several angles and then observe. Okay, let's take this angle as theta. Okay, then what is the length of hypotenuse, length of opposite, length of adjacent? You measure and write it here. And opposite side by hypotenuse, what is the ratio? Adjacent by hypotenuse. You write all this one. Okay, to your surprise, you will find that these ratios are constant. Okay, opposite by hypotenuse, adjacent by hypotenuse is constant for any right angle triangle where one of the angle is fixed. Okay, this angle A is always theta, right? Always same, whatever is this angle. Okay, so PB by AB, this ratio will be fixed, or PB by AP, this ratio is fixed. Okay, QC by AQ will be equal to PB by AP. This is what we are trying to prove with this experiment. So you see that these ratios will be same. Okay. Okay. So that's the experiment which we'll do. Now let's define trigonometric ratios. Okay. You have a triangle, right angle triangle. You will have three angles and three sides. Correct. So if you take opposite by opposite side by hypotenuse, okay, that ratio we call it as sine A. Okay, that ratio is sine A. Okay, if you take this example, opposite is BP by hypotenuse AP. BP by AP is sine A, because it is at angle A, if you see. Okay, or you can call it theta also, sine theta also you can call. It is at the angle A of the triangle. Correct. So opposite by hypotenuse is always called sine A. Okay, and cosine or cosine, whatever you call, is adjacent by hypotenuse. Adjacent by hypotenuse. So if you take this example again, what is adjacent for this theta or A? AB. AB by AP is cosine. Okay. AB by AP is cosine. Okay. Similarly, other triangle. Okay. Okay. So these ratios are always fixed. That's what we are learning. Okay. If you see here, sine A, sine of A, we represent it as sin A, sin A, or we call it, we pronounce always as sin A only. Okay. Okay. Is opposite length, which is BC, by hypotenuse, which is AC. BC by AC is sin A. Cosine is, or cos, we call it as sometimes cosine A or cos A. Cos A is adjacent by hypotenuse, that is AB by AC. AB by AC. Okay. And third one is tangent of A, tan A. Okay, tangent of A, or we call it in short tan A. Tan A is opposite by adjacent, that is BC by AB. BC by AB. Okay. Okay. So these are the three trigonometric ratios, which are the primitive, I would call. Okay. And whole trigonometry is based on these three ratios. Okay. Find sin C, cos C, and tan C in the adjacent triangle. Okay. First, let's find out sin C. C is here. Okay. So this is hypotenuse is 13 centimeters and BC is 5 centimeters. What is AB? 30, square root of 13 square minus 5 square. So you'll get 12. Okay. AB will be 12. So sine C is opposite by hypotenuse. So 12 by 13. 12 by 13. Cos C is 5 by 13. Adjacent by hypotenuse. 5 by 13. Tan C is 12 by 5. Okay. So this is also similar. You just draw the triangle, right angle triangle. X, Y, Y, Z are given. So you can find the third side. And then you have to use just opposite by hypotenuse and adjacent by hypotenuse, opposite by adjacent. Those three you will use. Okay. In a right angle triangle ABC, right angle is at C. Okay, so BC plus CA is 23 centimeters. BC plus CA. BC plus BC. Right angle is at C. Okay, sorry. So BC plus CA is 23 centimeters. That is opposite and adjacent. Two right angled sides are 23. BC minus CA is 7 centimeters. Okay. Then find sin A and sin B. Okay, if you use these two as equations, you can find BC and CA values easily. If you add both these equations, you'll get 2BC equal to 30. So BC is 15. If BC is 15, CA is 8. Okay. Now with that, you will get the AB value anyway from Pythagoras theorem. Then you can find sin A and tan B values. Okay. These things you have to try it yourself. Okay. Very simple. Once you are into the chapter, these are all these do this and try these sections are basically simple understanding of the theory above. Okay. Now let's discuss this. Does sin x equal to 4 by 3 exist for any value of angle x? Think about it. Sin x can be any value, right? Opposite by hypotenuse. But if you see the ratio, hypotenuse is the biggest side in a triangle. Correct? Hypotenuse is the biggest side in a triangle. This is the biggest side. Correct? So any other side of the triangle opposite will be always less than hypotenuse. So the ratio will be always less than 1. It cannot be 4 by 3. Sin x cannot be 4 by 3. Same thing, cos x also cannot be 4 by 3. Cannot be more than 1 basically. Okay. So the values of sin A and cos A are always less than 1? Yes. Because hypotenuse is the biggest side which is on the denominator. Correct? So numerator is always less than denominator. You will get less than 1 as the ratio. Okay. Is tan A is product of tan and A? No. It is tangent of angle A. Okay. Which is opposite by adjacent. Okay. So we know the three ratios, basic ratios. Okay. Uh, and we take reciprocal of all the three ratios basically. We call it cosec A. Okay. Is 1 by sin A. Okay. 1 by sin A is called cosec A. Sec A is 1 by cos A. Cot A cotangent or okay. This is cosecant. This is secant. This is cotangent. Okay. Cotangent is 1 by tan A. Okay. If you see these three are not these three are derived ratios basically from the three primitive ratios. Okay. So there is some usage of these ratios. Every time you don't want to see the reciprocal and solve the problems, right? So for that purpose, we have taken these values in mathematics. Okay. So if you see sin A is opposite by hypotenuse. So cosine cosec A will be 1 by sin A. That means it will be reverse. Ratio will be reverse. Hypotenuse by opposite side. So cosine and sec will be always greater than 1. These values will be always greater than or equal to 1. Okay. Similarly, sec A will be hypotenuse by adjacent. Okay. Cotan will be adjacent by opposite. Okay. Can you say sin A by cos A is tan A? Yes, definitely. Because if you see tan A is nothing but opposite by adjacent. Correct? Sin A is opposite by hypotenuse, adjacent by hypotenuse. So the denominators of both hypotenuse gets cancelled. So it is opposite by adjacent. correct? So sin A by cos A is equal to tan A, and cos A by sin A is cot A because it is inverse ratio, right? So these two are true. Let's do some examples here first. If tan A equal to 3 by 4, find the trigonometric ratios of angle A. Okay. So tan A is 3 by 4. So we will assume that uh, opposite is 3k and adjacent is 4k. Then only the ratio will be 3 by 4. Correct. So if you apply Pythagoras theorem, you will get AC as 5k. Correct. If you apply Pythagoras theorem on this one, you will get AC as 5k. Okay. Once you know that it is 5k, hypotenuse is 5k, all the ratios you can find out. Sin A is 3k by 5k, which is 3 by 5. Cos A is 4k by 5, 5k, which is 4 by 5. Then cosec is 5 by 3, secant is 5 by 4, and cot is 4 by 3. Okay. Yeah. Angle A and angle P are acute angles such that sin A equal to sin P. Sin A equal to sin P. Prove that angle A equal to angle P. Okay. As we have done one experiment before, for a different same angle A but different right angle triangles we took, the ratios are always same. Okay, the ratios are same because the angle is same. Okay, sine of angle is always same means, okay, the angle is same. Okay, so let's prove it. It's very easy with using similar triangles. Okay, uh, in triangle ABC, sin A equal to BC by AB. Correct, BC by, sorry, AC, BC by AC. Sin P equal to, sin P equal to QR by PQ, QR by PQ. Now it is given that these two are equal, correct? So BC by AC equal to QR by PQ. Let's say assume that this is K. Okay, this ratio is K. Okay. Now by using Pythagoras theorem, AB by PR equal to AB, which is AB by PR equal to, AB is nothing but square root of AC square minus BC square, and PR is nothing but square root of PQ square minus QR square. If I substitute these values, what I will get is, okay, AC by PQ. AB by PR equal to AB by PR equal to AC by PQ. Okay, which means if you consider these two triangles, the ratios of sides are same. Ratios of corresponding sides. Okay, AB ratio with PR, AB by PR is equal to BC by QR. Okay, and AC, which is equal to AC by PQ. Okay, if all sides, corresponding sides of two triangles are same ratio, we can call them similar triangles, right? These two are similar triangles, which means angle A is equal to angle P from similar triangles principle. Okay, all three angles will be equal actually. Corresponding angles will be equal. C will be equal to Q, R will be equal to B. Okay, so this is how we can prove it. Now, consider triangle PQR, right angled at R, in which PQ equal to 29, QR equal to 21 units, and angle PQR equal to theta. Find the values of cos square theta plus sin square theta, cos square theta minus sin square theta. Okay. So this is the given data. PQ equal to 29, QR equal to 21. So PR will be equal to, apply Pythagoras theorem, you will get 20 units. This is 20 units. Once you know that this is 20 units, okay, theta is here, sin theta is 20 by 29. 20 by 29. Cos theta is 21 by 29. Okay. Now you know these two values. So sin square theta plus cos square theta, you will get 1. Cos square theta minus sin square theta, you will get 41 by 841. Okay. So these are the basic examples of trigonometry based on the fundamental ratios of trigonometry. Okay. And how Pythagoras theorem and trigonometric ratios goes parallelly, combinedly, right, together. That is most important thing. You don't need to find all three sides of a all. You need to know all three sides. Okay, if one side is given, you can and one angle is given, you can find sides of other sides of the triangle. Okay, So let's get into the exercise part now. Let's get into the exercise 11.1. These are the basic questions of trigonometry. Okay. In a right angle triangle ABC, okay, already given right angle triangle, 8 centimeter, 15 centimeter, and 17 centimeters are the lengths of AB, BC, and CA respectively. Then find sin A, cos A, and tan A. Okay. In case this right angle triangle is not given, okay, first thing is we should do is prove that it's a right angle triangle. Then it's very easy to find the ratios. Okay. So how do you prove a right angle triangle? It should follow the Pythagoras theorem. Okay. You cross check it. Okay. So sin A is basically sin A is opposite by hypotenuse, which is 15 by 17 because A is here. Cos A is 8 by 17 adjacent by hypotenuse. Tan A is opposite by adjacent, that is 15 by 8. Okay. Yeah. Next. The sides of a right angle triangle PQR are PQ7, PR is 25, and Q is 90 degrees. Okay, find tan P minus tan R. Okay, so 7 and 25, this is what is given. You can find the third side using simple Pythagoras principle, right? Here, so which is 24. Once you know that tan P is opposite by adjacent, which is tan P, right? P is here, so opposite is 24 by 7. Tan R is 7 by 24. Okay, so tan P minus tan R is this value, which is nothing but 527 divided by 168. Okay, next. In a right angle triangle ABC with right angle at B, in which A equal to 24 units, B is 25 units, and angle A is theta, then find cos theta and tan theta. Okay, same problem. 24 and 25 are given. You just need to find BAC is BAC, that is A. This is theta. Okay. Then for cos theta, you need adjacent, which is nothing but 25 square minus 24 square, square root of that value. Okay, which is 7. Once you know this, cos theta is cos A, which is 7 by 25. Tan theta is opposite tan A, which is opposite by adjacent, which is 24 by 7. Okay, yeah. Next. If cos A is 12 by 13, find sin A and tan A. Okay, and A is less than 90 degrees. So this is construction of a, yeah, right angle triangle. Okay. Cos A is 12 by 13, so that is adjacent by hypotenuse. So 12k by 13k because it's a ratio. Okay. From this we can find the opposite. Opposite is nothing but apply the Pythagoras theorem. You get the opposite as 25k square. Opposite square is opposite side is 5k. So BC is 5k. Once you know this, the ratios of sin A is 5 by 13, tan A is 5 by 12. Okay. Next. If 3 tan A equal to 4, find sin A and cos A. Okay, yeah, this is simple. 3 tan A is 4, which means tan A is 4 by 3. So opposite by adjacent, that is 4k, 3k. So AC will be 5k. Okay, from Pythagoras theorem you can find easily. Okay, once you know that sin A is 4k by 5, 5k, which is 4 by 5. Cos A is 3k by 5k, which is 3 by 5. Next. Triangle ABC and triangle XYZ, if angle A and angle X are acute angles such that cos A is equal to cos X, then show that angle A is angle X. So we have seen exactly same problem in the examples. Only difference is it was given as sin A equal to sin X. Okay. So it's same basically. You have two triangles. What is trying to tell is the ratios are same. Okay. Cos A equal to cos X. Cos A is nothing but AB by AC. Cos X is XY by XC. Okay. Now this is ratio, let's call it K. Then from Pythagoras theorem, BC by BC square, BC square by YZ square equal to AC square minus AB square divided by XZ square minus XY square. So you will get finally AC square by XZ square. So ratios of corresponding sides are same in this uh, two right angle triangles, which means these two triangles are similar triangles. Once you know that these two are similar triangles, angles are same. So angle A equal to angle X. Okay. Next, this is basically reverse of the uh, trigonometric ratios. We are proving the reverse of trigonometric ratios. If the ratios are same, angles are same, basically. Okay. Next, a given cot x equal to 7 by 8, then evaluate these expressions. Okay. So all such problems first construct the rectangle triangle because cot x is given, x is here. So 7k by 8k, 7k and 8k, opposite is adjacent is 7k. So find the hypotenuse, which is using Pythagoras theorem, it is square root of 113k. Okay. Now you know these values. Simplify this first. This is 1 plus x into 1 minus x and 1 plus x into 1 minus x. So obviously this is 1 minus sine square x divided by 1 minus cos square x. So you know that 1 minus sine square x is 8 by square root of 113. So squares are there. So 8 square by 113 divided by 1 minus 7 square by 113, which is 49 by 64. Okay. So this is one ratio which they asked. Other one is 1 plus sin x by cos x. So which is 1 plus 8 by square root of 113 by 7 by square root of 113, which is 8 plus square root of 113 by 7. Okay. If they are asking up to some decimal points, you can simplify it and solve it. Next. In a right angle triangle ABC, right angle at B, if tan A equal to root 3, find the values of sin A cos C plus cos C sin A. Okay, exactly similar problem. As I said, you need to build a right angle triangle first. And A is here, tan A is given opposite by adjacent. So root 3 by 1. So find out AC. AC is nothing but apply the Pythagoras theorem, you get 2k. Okay, this is 2k, this is root 3k, this is 1k. Okay. Now sin A plus sin A cos C plus cos A sin C equal to root 3 by 2 into root 3 by 2. Just apply. You know where is A, where is C, you know. So you apply sine and cos ratios, cosine ratios. What you will get is 1. Okay. And cos A cos C minus sin A sin C is 0. Okay. So these are the kind of basic problems which you get in trigonometrics. We build based on these things to more advanced problems. Okay. Yeah, let's learn the trigonometric ratios. Trigonometric ratios. We already saw that the trigonometry is mainly relation between angles and sides of a triangle, or the ratios of sides of a triangle, right? So for a given angle, the ratio is constant. That also we have already saw the practice, right? So once we know this, we can make actually a table of some few important angles. We can actually make for any angle from 0 to 90. Okay, trigonometric ratio, but we can't remember everything. So we will make some ratios, constants, which are for some important angles, something like 0, 30, 60, 90, 45 also. Okay, so let's do one by one. First, let's go easiest one, which is 45 degrees. Okay, so 45 degrees, if you build a right angle triangle, you will have a isosceles right angle triangle. Okay, where the adjacent and opposite both are 1 and 1, and hypotenuse is square root of 2, right? So once you know that sine 45 is opposite by hypotenuse, so 1 by square root of 2. Okay, 1 by square root of 2, and cos 45 also 1 by square root of 2. Okay, and tan 45 is 1 by 1, which is 1. Okay, and similarly you can get cosec 45, sec 45 and cot 45, which are reciprocals of sine, cos and tan, right? So we have now trigonometric ratio for 45 degrees angle, correct? So this is the first one. Now let's see how to do it for 30 degrees and 60 degrees. Okay, so in this case you take a equilateral triangle. Okay, you have a equilateral triangle, so all three sides are same. So if you take one of the side as 2a, 2a, and other side is also 2a, and you draw a perpendicular from a onto the uh, BC side BC. Okay, so D is at D there is a perpendicular, that is 90 degrees angle is made. So we know that in a equilateral triangle, perpendicular bisects the opposite side. which means BD equal to A, BC equal to A. Okay. Now you have hypotenuse. If you take a triangle A, B, D, at one side you have 30 degrees. Okay, at one side you have 60 degrees and a 90 degrees. And you have sides which is opposite to 30 degrees is A, opposite to 90 degrees is 2A. So opposite 60 degrees is we can derive it because it's a equilateral triangle. You apply Pythagoras theorem, what you will get is root 3. Root 3 is what you will get. Okay, square root of 3A. Okay, so once you know this, we can derive trigonometric ratios for 30 and 60 as well. Correct. So if you take sine 60, okay, sine 60, 60 is here, opposite is square root of 3 by 2. Square root of 3 by 2. Cos 60, 1 by 2. Okay. And similarly, sine or tan 60, root 3 by 1. Okay. Similarly for 30 also. Sine 30 is 1 by 2. Okay. So cos 30 is root 3 by 2. Tan 30 is 1 by root 3. Okay. So now you got trigonometric ratios for 30 degrees and uh, 60 degrees also, along with 45, which we have done already. Okay. So for cosec, sec, and cot, obviously they are all inverse, right? So find the values of cosec 60, sec 60, and cot 60. Yeah, this is simple actually. Sin 60 is root 3 by 2. So cosec 60 is 2 by root 3. Uh, Cos 60 is 1 by 2. So sec 60 is 2. Tan 60 is root 3 by root 3. So cot 60 is 1 by root 3. Okay. So similarly, these values also you can tell. Now, how to find out trigonometric ratios for 0 degrees and 90 degrees? Okay. So here we need to do some assumption. Okay. You have a triangle like this. Okay. As we know, when this theta will be 0 degrees, as AC will fall onto AB. Correct. Only when AC will exactly fall onto AB. In that case, what happens to the BC? BC is almost 0. As theta approaches 0, BC becomes 0 and AB and AC will be equal. Correct? Once you know this, okay, sine 0 is equal to this will be 0. 0 by something is 0. Sine 0 is 0. So, okay. And what is cos 0 adjacent by hypotenuse, which will be equal once if this angle is 0, these two will be same. So it will be 1. Okay. And tan is nothing but sine by cos. So 0 by 1, which is 1. And you have cosec, sec, and cot, which are exactly reciprocals of this period. Okay. So only thing to know is cosec 0 if you take or cot 0 you take, it is 1 by sine 0. Cosec 0 is 1 by sine 0, correct? So sine 0 is 0, we said. So this is not defined. Okay, cosec 0 and cot 0 are not defined. Okay, so you have to note it down. Okay, next. So we have got and cot 0 also same, it is not defined. Sec 0 equal to 1 because it is 1 by cos 0 is 1. So sec 0 is 1, right? So this is how we got the trigonometric ratios for 0 degrees. Now let's go for the 90 degrees. Exactly same what we do. If this angle here becomes 90 degrees, okay, CY or CB basically, CB will be equal to AC. CB will become equal to AC and AB will become 0. Okay. So once you know this, again you can derive sine A. Sine A is nothing but opposite by hypotenuse. So opposite and hypotenuse will be 0 for 90. So it is 1 by 1 basically. Sine 90 is 1. Okay. And cos 90 is adjacent by hypotenuse. Adjacent will become 0 if it is 90 degrees. It goes to 90 degrees. So 0 by whatever number. So it doesn't matter. 0 by something which is 0. Now we know tan. Tan is nothing but sine by cos. So it will be 1 by 0. It is not defined. Okay. And similarly, you can find the other ratios. Okay. So this is how we find. And once we know all these angles, you just tabulate. Okay. make a table of all these ratios. These are the important ratios which we should remember. You can find out trigonometric ratio for any angle, but these are the important things to remember. Okay, so sine you have 0, 30, 45, 60, and 90, and these are the trigonometric ratios: sin A, cos A, tan A, cot A, sec A, and cosec A. Okay, so it goes like this. 0, sin 0 is 0, sin 30 is 1 by 2, sin 45 is 1 by root 2, sin 60 is root 3 by 2, sin 90 is 1. And if you see cos A, it is exactly, you write in a reverse way, correct? 1, 1, root 3 by 2, root 3 by 2. 1 by 2, 1 by square root of 2 is same. 1 by 2, 1 by 2, 0, 0, exactly reverse. Tan we can always derive from sin A and cos A, so it will come, okay? And cot A is reverse of tan A. Sec A is 1 by cos A, so you will can get it. So only thing you have to remember is these values. If you remember this, rest all values you can derive. And another easy way to remember is you write in order these angles 0, 30, 45, 60, 90. Okay. Now you make it 0 by 4. First one, right? First one is 0. So 0 by 4 is 0. Okay. Square root of 0 by 4 basically. Okay. Second one is 1. This is the first one. This is 0th term. This is first term. So 1 by 4 square root. Square root of 1 by 4, which is 1 by 2. Okay. Now this is second one. So 2 by 4 square root of 2 by 4, which is nothing but 1 by root 2. Okay. This is third one. So square root of 3 by 4. Square root of 3 by 4, which is root 3 by 2. Fourth one is 4 by 4. Square root of 4 by 4 is square root of 1, which is 1. Okay. So that way you can easily remember by giving 1, 2, 0, 1, 2, 3, 4, all divided by 4 and square root of. Okay. So once you remember this, rest all values are easy to remember. Okay. Okay. So here there is something given. If A is greater than or equal to B, then sin A is greater than or equal to B. Yes, it is true. Sin A value will increase with the angle up to 90. After 90, again, it's a sign. If you actually plot a graph, you will know it later when you find out for more than 90 degrees. Okay. So it will go down. Okay. In within 90 degrees, if angle is between 0 to 90, sine value always increases. Cos value decreases 1 to 0. Okay. So you can remember these things. Okay. Let's do some examples. In ABC, right angle is at B, AB equal to 5, ACB equal to 30 degrees. Now you see, they are not giving two sides. Now you don't need two sides because you already know what is the ratio of 30 degrees. Trigonometric ratio of 30 degrees you already know. So you just need one side. Okay. Determine the lengths of other sides BC and AC. Okay. So now you know that this is 5 centimeters, this is 30 degrees. Okay. To find out AC, what you need is sine 30. Sine 30 equal to 5 by, let's say this is x, AC is x. 5 by x equal to sine 30. Sine 30 we know, sine 30 value is 1 by 2, correct? So 1 by 2 equal to 5 by x. So this will be 10. AC will be 10, right? So, and to find out BC value, either you use cos sign because you already know this is 10, or you can use a tan value, tan 30 you can use, okay? So any of that you can use and you will get the values of other two sides. So you just need one angle and one side, that's enough. You can find out rest all sides and angles also, of course, because it's a right angle triangle. We know that this is 60 here. Okay. Next example. A chord of circle of radius 6 centimeters is making an angle 60 degrees at the center. Find the length of the chord. Okay. So this is the chord. This chord is making angle of 60 degrees at the center. So this angle AOB is 60 degrees. Okay. So obviously we know if you draw a perpendicular, AOC is 30 degrees, COB also 30 degrees. Okay. Find the length of the chord is what we need to find out. Length of the chord is exactly double that of AC, 2 times AC or 2 times BC. Now you know this is 6 centimeters, this is 30 degrees. Okay. So sine 30 equal to BC by OB. Correct. This is also 30. BC by OB. Okay. So 1 by 2 equal to BC by 6, which is 3 centimeters. So BC is 3 centimeters. So AB is twice, that is 6 centimeters. AB also 6 centimeters. Okay. So just a historical note, don't think that trigonometry is mainly coming from Europe actually. That's wrong actually. So most of the Europeans also thought actually trigonometry was from uh, Persian, basically from Persia or Arabic countries, Arabic knowledge they thought, but it was there in India much before. Okay, the first use of idea sine, okay, is very very way back to 500 CE, and it is used by Aryabhatta in his famous book Aryabhattiyam. Okay, he called Ardhagnya. He called it Ardhagnya. Sine is called Ardhagnya. Okay, that is the short form. It is Gnya, and over the time it has become Jiva. Okay, it has become uh, Jiva. Here you can see here, right? Okay, and when this Aryabhattayam was translated into Arabic, the word Jiva was written as it is. Okay, but when it is translated from Arabic to Latin, at the time they used exactly the meaning of Jiva. Uh, okay, into sinus. They call it sinus, and from sinus, the word sine came. Okay, so this is the journey of sine wave actually. The word sine, it all the way started from India. Okay, as Ardha Jiva, Ardhagnya, Jna, Jiva, then sinus, and then sine. And one English professor has used a short form SIN. So that's how it has come. Okay, so it's an interesting history. Now another example. In triangle PQR, right angle is at Q. Okay, PQ is 3 centimeters. PR is 6 centimeters. Find the QPR. QPR. Okay. So if you take this angle as theta, okay, this will become adjacent hypotenuse. So sine cos theta equal to 3 by 6. Cos theta is, okay, or sine R, whatever. Okay. Cos P equal to 3 by 6, which is 1 by 2. Correct? 1 by 2. So this will be 60 degrees, right? QPR is 60 degrees then. Cos 60 is 1 by 2, right? Or you can use this R and then subtract uh, 90 minus R. That's what he has done here, but you can use a cos theta. Okay, cos P equal to 3 by 6, and 3 by 6 is 1 by 2. And we know that cos 60 is 1 by 2, so P is 60 degrees. Okay, so yeah, this is fine, very simple thing. Sin A minus B equal to half, sin cos A plus B equal to half, where A plus B are between 0 and 90. Find if A is greater than B, find A and B. Okay, this is simple. We know that sin A minus B is half, which means A minus B equal to 30 degrees because sin 30 is half. So A minus B is 30 degrees. Cos A plus B is half. Okay, we know that cos 60 is half. So A plus B equal to 60. Now these two are equations. If you sum them up, you will get 2A equal to 90 or A equal to 45 degrees, B is equal to 15 degrees. This is how we solve the problem. Okay. Yeah, let's do the exercise part. Let's do exercise 11.2. Okay. Sin 45 plus cos 45. So these are all you have to just remember the table which we have just now showed. Complete table, right, of all trigonometric ratios of the important angles. So this is 1 by root 2 plus 1 by root 2, right? Which is nothing but 2 by root 2, which is simplified to root 2. Okay. Cos 45 divided by sec 30 plus cosec 60. Okay. So again, you have to just substitute values. That's all. There is nothing special in this. 1 by root 2 into 1 by 2 by root 3 plus 2 by root 3. Okay. Which is nothing but this square root of 3 divided by 4 square root of 2. Okay. So third one is sin 30 plus tan 45 minus cosec 60 divided by cot 45 plus cos 60 minus sec 30. So if you see here actually sin 30 is same as cos 60, tan 45 is same as cot 45, cosec 60 is same as sec 30. So you should get one. Simple, right? Yeah, that's it. Next is 2 tan square 45 plus cos square 30 minus sin square 60. Okay. So again, you substitute the values. What you will get is 2 plus 3 by 4 minus 3 by 4, which is 2. Okay. Secant square 60 minus tan square 60 divided by sin square 30 plus cos square 30. Okay. So again, substitute the values. What you will get is 1. Okay. Next, choose the correct option. 2 tan 30 divided by 1 plus tan square 45. Okay, which is equal to which of these values basically. Okay. So if you substitute the values, what you will get is 1 by root 3. 1 by root 3 is nothing but tan 30. Okay. So answer is C. 1 minus tan square 45 divided by 1 plus tan square 45. Okay. So tan square 45 is 1 we know. So value is 0. So D is the answer. 2 tan 30 divided by 1 minus tan square 30. Okay. So substitute the values, you'll get root 3. Root 3 is nothing but tan 60. Right? Yeah. Next. Evaluate this expression. Okay. What is the value of sine 60 plus 30? What can you conclude? Okay. So this value, if I substitute the values, I'll get 1. Okay. Then sine 60 plus 30 also sine 90, which is 1. So we can say that sine 90 is equal to, or sine 60 plus 30 is equal to sine 30, sine 60 cos 30 plus sine 30 and cos 60. If this is valid for all the angles or not, we will do it later. Okay. But right now for 90 degrees sine, I mean 30 and 60 and 30 degrees, it is valid, this equation. Is it right to say cos 60 plus 30 equal to cos 60 cos 30 minus sin 60 sin 30? Let's just substitute values and see. Okay, cos 60 plus 30 is 0 and this one also 0. So yeah, we can say that both are equal. And as of now, this is valid only for 30 and 60 degrees. Okay, not more than that. Okay, for generalizing, we need to prove it. This is not a proof. This is only example applicable for one particular value. In a right angle triangle PQR, right angle is at Q, PQ equal to 6 centimeters, RPQ equal to 60, determine the length of QR and PR. Yeah, we have done this example actually already. One side is given, one angle is given, right? So very simple. Tan 60 is QR by PQ. So QR by 6 equal to root 3, tan 60 which is, so QR is 6 root 3, okay? And cos 60 equal to PQ by PR, PQ by PR, which is 1 by 2, okay? So PR equal to 6 into 2, which is 12. This is 12. PR equal to 12. Okay. So in a triangle XYZ, right angle is at Y, YZ equal to X, XZ equal to 2X, and determine these two angles, X and Z angles. Okay. This is X, this is 2X. You have to determine the angle X and Z. Okay. Now let's take sin X. Sin X is nothing but YZ by XZ, which is 1X by 2X, which is 1 by 2. Which means X is 30 degrees. X is 30 degrees, other angle is 60 degrees because it's a right angle triangle. Okay, next. Is it right to say that sin A plus B equal to sin A plus sin B? Justify your answer. Yeah, at least to prove it is wrong, we just need one wrong answer to prove that it is wrong. So I have taken A equal to 30, B equal to 60. Okay, sin A plus B is 1, but sin A plus sin B is nothing but root 3 plus 1 by 2. So both are not equal, which means it is not correct. It's not correct to say that. Okay, next. Trigonometric ratios of complementary angles. Let's do this. Trigonometric ratios of complementary angles. Okay. We know what are the complementary angles? X and 90 minus X both are complementary angles. Okay. So if you know X and 90 minus X are complementary angles, they are basically two acute angles of a right angle triangle. Okay. X and 90 minus X are exactly acute angles of a right angle triangle. Okay. Now, what is the relation between these trigonometric ratios? Sine of C is equal to cos of A, correct? Sine of C is equal to cos of A, okay? Tan of C equal to cot of A, okay? So if you see all that table which we prepared actually, okay, you can easily observe that sine of 90 minus x equal to cos x. Sine of 90 minus x equal to cos x. Cos of 90 minus x equal to sin x. Tan of 90 minus x equal to cot x. Cot of 90 minus x is tan x. And cosec and sec also complementary are same for the complementary angles. Okay. So once we know this, this is what we can derive actually. Okay. These are the derived values of the complementary angles. Okay. From there to here, all are. Okay. Once you know this, actually this is very easy to understand from the table which we have drawn for all the important angles. Okay. Now let's see some examples. Evaluate secant 35 by cosec 55. Okay. So cosec A equal to secant 90 minus A. So if I substitute this, cosec 55 is cosec 90 minus 35. Okay. So cosec 55 is nothing but secant 35, which means, right? Because cosec 90 minus complementary angle is always secant. So given value is basically ratio of 1. Okay. Next. Cos 7a equal to sin a minus 6, where 7a is acute angle. Find the value of a. Okay. Now we know that cos 7a equal to sin of a minus 6. Sin of 90 minus 7a is nothing but cos 7a. I've been rewriting. Now these both are sine. Sin 90 minus 7a equal to sin of a minus 6. So these two angles 90 minus 7a is equal to a minus 6. Once you know this, a is 12. Okay. Next. If sin A equal to cos B, then prove that A plus B equal to 90 degrees. Yeah, this is easy because we know that cos B equal to sin of 90 minus B, correct? Now it is given that sin B is equal to cos B. Okay, sin A equal to cos B, it is given. Okay, so which means sin A, there is no 4 actually, sin A equal to sin 90 minus B. So A is equal to 90 minus B, that means that is A plus B equal to 90. Okay, express sin 81 plus tan 81 in terms of trigonometric ratios of angles between 0 and 45. Okay, now let's see how to do this. Sin 81, we can write it as sin 90 minus 9, which is cos 9. Tan 81, you can write it as cot 9. Okay, sin 81 plus tan 81 is cos 9 plus cot. Okay, cot 9. Okay, so this is between this angle 9 is basically between 0 and 45. So this is what we are expressing it. Okay, okay, next. If ABC are interior angles of triangle ABC, then show that sin B plus C by 2 equal to cos A by 2. Okay. So given that ABC are angles of triangle ABC, then A plus B plus C is 180 degrees. Once we know that A plus B plus C is 180 degrees, you divide it by 2. A by 2 plus B plus C by 2 equal to 90 degrees. So B plus C by 2 equal to 90 minus A by 2. So B plus C by 2 and A by 2 are complementary. Once you know that they are complementary, it's very easy to tell this value, correct? Hence proved. Let's do the exercise 11.3. Okay. Evaluate tan 36 by cot 54. It's nothing but cot 90 minus 36. So it's a complementary angle. So tan 36 by tan 36, which is 1. Cos 12 minus sin 78. Cos 12 is same as cos 90 minus 78 minus sin 78. So cos of complementary angle. So it is sin 78 minus sin 78, which is equal to 0. Cosec 31 sec minus secant 59. Okay, again complementary angle, so you'll get 0 value. Okay, next sin 15 into sec 75. Okay, this is nothing but sine 15 into secant 75. Secant 75, I can write it as secant 90 minus 15. So complementary of this one is cosec 15, which is equal to sine 15 into cosec 15. So which is equal to 1. Next, tan 26 into tan 64. Okay, tan 26 into tan 90 minus 64. So the complementary trigonometric ratio of this one is cot 26. Tan 26 and cot 26 are reciprocals to each other. So 1. Next. Show that tan 48, tan 16, tan 42 and tan 74 equal to 1. Okay. So you can see clearly there is a complementary angles. 42 and 48 are complementary to each other. 74 and 16 are complementary to each other. So if I write them as, you get tan 48, cot 48, tan 16, cot 16. So they're all reciprocals to each other. So we'll get value of 1. Next. Cos 36 into cos 54 minus sin 36 into sin 54 equal to 0. Prove that. Okay. So take LHS first. Okay. And replace with the reciprocals on one of the sides basically. Okay, 90 minus 36, you can write it as 90 minus 54. 54 can be written as 90 minus 36. From that, you will get cot 36 into cot 54 minus cos 36 into cos 54 minus cos 54 into cos 36, which is equal to 0. If tan 2a equal to cot a minus 18, where 2a is acute angle, find angle A. Okay. Yeah, you just write the complementary angle, both should be tan, then you can equate the angles. So tan 90 minus a minus 16 equal to 108, tan 108 minus, sorry, this is 18 actually, which is equal to 90 plus 18, which is 108 minus a. This is given that this is equal to tan 2a, right? So 2a equal to 108 minus a, or a is equal to 36 degrees. Next. Tan A equal to cot B, where A and B are acute angles, prove this one. This exactly same one was there in the examples actually. So very easy. You can check it yourself. ABC are interior angles of ABC. Triangle ABC show that, okay, tan of this is also exact problem was there in the uh, examples. Okay, we have solved it for instead of tan and cot, we solved it for I think sine and cosec. So you can check this. Express sin 75 plus cos 65 in terms of trigonometric ratios of angles between 0 and 45. You take complementary angles, okay, 90 minus 15, 90 minus 25. Sine will become cos 15, cos will become sine 25. Okay, trigonometric identities. Let's do this. Trigonometric identities. Okay, so here we derive some of the trigonometric equations which are most important. Okay. Let's directly go. We know this is a right angle triangle. So AB square plus BC square equal to AC square. We know AB square plus BC square equal to AC square. If I divide both the sides with AC square, then what I will get is AB square by AC square plus BC square by AC square equal to 1. Okay. So AB by AC is nothing but cos A. BC by AC is nothing but sin A. So sin square A plus cos square A equal to 1. This is one of the very important and basic trigonometric identity. Okay, many things will derive from this one, and most of the trigonometric equation we solve using this one. Okay, so same thing you can basically, if you divide with, let's say, cos square a on both sides, 1 plus tan square a equal to sec square. Okay, so which is nothing but this one, 1 plus tan square equal to sec square. And we also can say that cot square plus 1 equal to cosec square. Okay, these two we can derive from the main one, which is this one. You divide it with sin square A or cos square A, you will get the other two. Okay, are they? The question here is, yeah, this is important to note down. So this identity holds good for all the values from 0 to 90. Okay, these two holds good for all the values from 0 to 90. Basically any angle A, it will hold good. Now, yeah, this is very simple. We can easily solve this. You build a triangle, you will get it. Nothing very special. So you can do it yourself. And this one we know already. You can substitute the values, the complementary angles you can take. Sine square 15 plus cos square 15 it will become, which is 1. Okay. And here you will get cos square 36 plus sine square 36, which is 1 again. So 1 by 1, which is 1. Similarly, all these things we will solve like this. Let's do some examples, then we'll get into the exercise. Similar problems are there. Cot theta plus tan theta equal to secant theta into cosec theta. We have to prove this. Okay, take the LHS. Cot theta plus tan theta is nothing but cos by sine theta plus sine by cos theta, and it will become sine square cos square theta plus sine square theta by sine theta cos theta, which is 1. Numerator is 1. We know this. Okay. Once this is 1, the numerator is 1, it will become 1 by sine theta cos theta, which is nothing but cosec theta and sec theta, right? So that is the RHS. Show that tan square theta plus tan power 4 theta equal to secant power 4 theta minus secant square theta. Okay, so take the LHS, take tan square theta common, 1 plus tan square theta, okay, which is equal to 1 plus tan square theta is nothing but secant square theta. So you put it, and tan square theta is nothing but secant square theta minus 1. Okay, so which is nothing but secant power 4 minus secant square theta. This is RHS. Okay, prove that square root of 1 plus cos theta divided by 1 minus cos theta equal to cosec theta plus cot theta. Okay, yeah. So first multiply with 1 plus cos theta on numerator and denominator. So you will get this value. This is nothing but sine square theta denominator. So which is equal to 1 plus cos theta by sine theta, which is nothing but cosec theta plus cot theta. That's RHS, which we are looking. Okay. Let's do the exercise 11.4. Simplify 1 plus tan theta plus secant theta into 1 plus cot theta minus cosec theta. Okay, so yeah, this is the one. So sine tan theta I wrote it as sine theta by cos theta plus 1 by cos theta. Okay, and similarly here. So this will become cos theta plus sine theta plus 1 into sine theta plus cos theta minus 1 divided by cos theta and sine theta are LCMs of both of these. So sine theta cos theta divided by. Okay, so this is nothing but if I expand it, it will become sin theta plus cos theta whole square minus 1, because this is a plus b, a minus b. Okay, so if I expand it, it will become sin square theta plus cos square theta plus 2 sin theta cos theta minus 1 divided by sin theta cos theta. This is nothing but 1 plus 2 sin theta cos theta minus 1 divided by sin theta cos theta, which is 2. Next. Okay, simplify this one. Sin theta plus cos theta whole square plus sin theta minus cos theta whole square. Okay, sin theta plus cos theta. You can expand it, sin square plus cos square plus 2 sin theta cos theta plus sin square theta plus cos square theta minus 2 sin theta cos theta, which is 1 and 1. Other 2 gets cancelled. So 2. Now this one. Yeah, this is a straightforward question. This is secant square minus 1 is tan square theta. Cosec square minus 1 is cot square theta. So tan square theta into cot square theta, which is 1. Show that cosec theta minus cot theta whole square equal to this value. Okay, take the LHS. Okay, write it as 1 by sine theta minus cos by sine whole square. Okay, which is nothing but 1 minus cos theta into 1 minus cos theta by sine square theta, which is equal to sine square theta. I write it as 1 minus cos square theta. Okay, so 1 minus cos theta into 1 plus cos theta, 1 minus cos square, right? So if I do this, I'll get the required RHS. Next. Show that square root of 1 plus sine theta by 1 minus sine theta equal to secant A plus tan A. Okay. So I am multiplying both numerator and denominator with 1 plus sine A. Okay. So it will become this value, and that is nothing but 1 plus sine A by cos A, which is nothing but secant A plus tangent A. Okay, which is RHS. Next. 1 minus tan square a by cot square a minus 1 equal to tan square a. Show that. Okay, again take LHS. Okay, tan square a is nothing but sin square by cos square a by sin square a minus 1. So if you do simplify this, basically both the numerators gets cancelled. So you are left with 1 by cos square a divided by 1 by sin square a, which is nothing but sin square a by cos square a, which is tan square a. Next. Show that 1 by cos a minus cos a equal to tan a into sin a. Okay. Yeah, this is simple. Uh, you just take LCM. 1 minus cos square a by cos a. This is nothing but sin square a. 1 minus cos square a is sin square a. So sin square a by cos a, which is nothing but sin by cos is tan, and 1 sin a is left, sin a. RHS. Simplify secant a into 1 minus sin a into secant a plus tan a. Okay. So yeah, this is pretty simple. You first take secant a inside. Okay. And then if you multiply, I'll get is secant square a. Okay. Minus tan square a, because this is tan a. Sin a divided by cos a is tan a. So a plus b into a minus b into a plus b. So sin secant square minus tan square a, which is nothing but 1. Okay, prove this one. LHS is this value. Now expand it. Sin square a plus cosec square a plus 2 plus cos square a plus secant square a plus 2. So 4 is there already. And then I get sin square a plus cos square a plus cosec square and secant square, which is equal to 4 plus 1, 5, 5 plus some value here. Okay. Now this also I will write it as into 1, and this one I am writing as sin square a plus cos square a. I am just multiplying with sin square a plus cos square a. Okay. This is nothing but sin power 4a plus cos power 4a plus 2 sin square a cos square a. This, if I expand it, I can expand it like this. Okay. This 2 and 2 sin square a cos square a divided by sin square a cos square a is 2. So this 2 I am taking out, integer 2, adding it to 5. So it is 7 plus this value. This is nothing but tan square a plus cos square a, cot square a. Okay. Yeah. Next. Simplify this value. Simple. This is 1 minus cos square a into 1 plus cot square a. If I expand it, what I will get is sin square a. This is nothing but sin square a into 1 plus cot square a. That is nothing but sin square a plus cos square a, which is equal to 1. Next. Secant a plus tan a equal to p. Then what is the value of secant a minus tan a? Okay. We know that the secant square a minus tan square a equal to 1. So I can write it as secant a plus tan a into secant a minus tan a. This value is given as p. So other value is 1 by p. Okay, cosec a plus cot a equal to k. Then what is the value? Then prove that cos a is this value. Okay. So this is also same way we will prove cosec square minus cot square equal to 1. Okay, which means, okay, we know this value. Then k square minus 1 into divided by k square plus 1 is nothing but cosec square plus cot square plus 2 cosec cot minus 1, and this value. If you simplify it, what you will get is cot square cosec square a minus 1 is nothing but cot square a. So 2 cot square a plus this value. And here cosec square a plus, sorry, cot square a plus 1 is nothing but cosec square a. So 2 cosec square a plus this one. You take the appropriate things common, then what you are left with and what you have is cot a by cosec a, which is nothing but cos a. So cos a is this value. Okay. Next. Yeah, optional exercise. Okay. Prove that cot a minus cos a divided by cot a plus cos a equal to cosec a minus 1 divided by cosec a plus 1. You can take LHS and go to RHS, or you can take LHS and RHS and come to the same value. That's also other way. let's try this one. Take the LHS. I take the cos A common. So it will become 1 by sin A minus 1 into 1 by sin A plus 1. Okay, so cos A gets cancelled. So 1 by sin A is nothing but cosec A. So cosec A minus 1 divided by cosec A plus 1. Okay, so this one, similar, similar. I'm dividing both numerator and denominator with cos A. So it will become tan A minus 1 plus secant A divided by tan A plus 1 minus secant A. Okay, so I write this 1 as secant square minus tan square A. Okay, then if I take secant square minus tan square A common, this is what it will become, secant A plus tan A minus 1, which is same as numerator. So numerator, denominator, this value gets cancelled. We are left with 1 by secant A minus tan A, which is nothing but uh, RHS. Okay, prove this value. All the trigonometric problems, if you see, are very simple. What you have is very introductory level problems actually. More advanced you will get in 11th and 12th. And if you are really writing the Olympiad, you get the advanced problems. Okay. And these are all very introductory level problems which are very, very straightforward. So don't miss them. Practice once. You should get 100% marks in trigonometric problems in 10th class exam very easily. Okay. You don't even lose time. Okay. Secant A minus sin A into secant A, sorry, cosecant A minus sin A into secant A minus cos A, which is, if I expand it, write it like this, then it will become 1 minus sin square A into 1 minus cos square A divided by sin A by cos A. So this is nothing but sin A cos A divided by 1 I will put, because I require to get to here. 1 by tan A plus cot A I should get to. Right? So sin A cos A divided by sin square A plus cos square A. If I take this as, rewrite this as 1 by sin square A by sin A cos A plus cos square A by sin A cos A, then the value is what we are looking for, 1 by tan A plus cot A. Okay, so, this is exactly similar to the previous one. Okay, so you can do it. You just check the steps and you can do it yourself. Okay, then prove that 1 plus secant A by secant A equal to sin square A divided by 1 minus cos A. Okay, so this one I'll write it as this. Then it will become cos A plus 1. Okay, and I am multiplying both numerator and denominator with 1 minus cos A. Then it will become 1 minus cos square A divided by 1 by 1 minus cos A, which is nothing but sin square A divided by 1 minus cos A. Okay, you look at the LHS and RHS carefully, and you have to transit to those trigonometric ratios from given trigonometric ratios. From LHS ratios, you have to transit slowly to RHS trigonometric ratios. And mostly we will use only one, sin square A plus cos square A equal to 1, and its variations, two other variations. Those are the things we use. Okay, yeah, this one. So this is very easy. First one is very easy. 1 plus tan square A plus 1 plus cot square A is nothing but, this is secant square A, this is cosecant square A, which is nothing but tan square A. So this one is proved. Now let's look for this one. Tan square A is nothing but tan A into 1 minus cot A into divided by 1 by cot A full square. Okay. So this is nothing but tan A minus 1 divided by 1 minus cot A whole square. Right. I can write it as tan A minus 1 or 1 minus tan A. It doesn't matter because we are in the square. Okay. Prove that secant A minus 1 divided by secant A plus 1 equal to 1 minus cos A divided by 1 by 1 plus cos A. This is very straightforward question. Okay. Just write secant A as 1 by cos A, then you will get the values. Yeah, that's all. So this is the very basic introduction of trigonometric. We have another chapter for trigonometric applications in 10th class maths. We will get more problems to solve there. This is basically to get you hands-on with the trigonometric ratios and understand the relations between the sides and angles of a triangle. Okay, thank you. We'll come up with more Yeah, chapters.